Oh, Scholar Strife, doing some math. Today, in geometry, we're gonna apply deductive reasoning. So let's learn about the law of detachment. If a conditional, so if and if then a statement is true, then both the hypotenuse and its conclusion will be true. And then law of syllogism. If hypothesis P, then conclusion R. If hypothesis Q, then conclusion R. If both of those statements are true, then you can write it if P, then R. So let's do an example. I like to use if A, then B. If B, then C. That means A leads to C. So here's an example. So our first statement, if it is sunny, then it will get hot. And then the second statement, so here's the if P, then Q. And then if Q, then R. If Q, then R is if it is hot, or if it gets hot, then I want a fan. So if both of these are true, then you can say if it is sunny, then I want a fan. And basically, you can skip all the previous steps where, if it's sunny and then it's hot, then I get a fan. Or if it's raining, then it floods. Or so let's use a different example. If the dam, like say you have a water dam next to a city, so if the dam breaks, the city will flood. If the city floods, then people will die. So you can say if the dam breaks, then people will die. So that is the law of syllogism, or also known as the chain rule. So we're going to use the law of detachment to make a valid conclusion. So if two angles have the same measure, then they are congruent. So we can just say angle A is congruent to angle B. Jeff goes to the gym every weekday. Today is Monday. That means Jeff will go to the gym. Yeah, if we know that Jeff goes to the gym every weekday, and we know that today is Monday, that means he'll be at the gym. Or at least he will go to the gym. Use the law of syllogism to write the next conditional statement. So, if Leslie eats lunch today, then she will eat a sandwich. If she eats a sandwich, then she will drink a glass of milk. So I can say, if Leslie eats lunch today, then she will drink a glass of milk. So if x squared is greater than 36, then x squared is greater than 30. If x is greater than 6, then x squared is greater than 36. So for this one, we need to examine it because it didn't line it up as easily. So let's say if in fact, I did this backwards. So let's say if this is A, so if A, then B, then B, then C. So I'm going to say if x is greater than 6, then x squared is greater than 36. If x squared is greater than 36, then x squared is greater than 30. So that one was a little bit tricky because they rearranged our letters. So like in the Leslie sandwich, so if Leslie eats lunch today, that's A. She'll eat a sandwich, B, then glass of milk, C. So that one led straight to the end there. This one, they gave you the second statement first and then the first statement. See, if a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all of its interior angles are congruent. So notice that this first part is the same as this part here. So I'm going to say so we got if a triangle is equilateral, so let's call this the A statement, and then all of its sides are congruent. And then they repeat that first statement again. If A, then something else. Because what we need is we need A going to B and B going to C to say that A is going to C. But in this we have A going to B and then A going to C. So this one we cannot do. So this one's not possible. The conclusions don't match either hypothesis. Alright, tell whether each statement about the graph is a result of inductive or deductive reasoning. Explain your answers. So the runner's average speed decreases as the time spent running. Okay, that's inductive because that's based on a trend. Based on this general trend. The runner's average speed is slower when running 40 minutes than when running for 10 minutes. So this is deductive because it's based on the facts given. And I think that's it for this one. Yep. Have a good one.